Hi, Assalamualaikum. My name is Muhammad ALWI. Today, I would like to present my FYP project titled Cloud Storage NAS with Secure Offsite Backup. With the current technologies keep evolving advancing, the probability of building a server for their own users in daily life is no longer an impossible task. Images of open software in the current trend is never able to build a physical storage to store any portable file, or specifically known as network storage or NAS. This means that any normal people can build a NAS with by buying their hardware, for example like the QNAP or Synology, or build their own using an old PC or laptop to convert it into the NAS. For the problem statement, NAS alone is not enough to be the sole backup for the data, since the NAS tend to be on the same network. Henry and Poe in 2017 said data backup is important in the long and short term, as more people want to store their important data on the computer. In terms of security, there are three factors that need to be considered when installing a file server, which are data confidentiality, integrity, and availability. It is important to know which protocol to use to secure those data. In a research paper conducted by ICRAP et al. In 2016, it is found that while 67% of VPN Android apps found offer service to enhance privacy and security online, most of 75% of use third-party tracking libraries, and 82% request permission to access sensitive resources like user account and text message. This is extremely dangerous to normal user, as they are breaching privacy issues. For the project objectives, first objective is to design and configure NAS for small home office with offsite backup. Second objective is to configure OpenVPN for secure connection when transferring file. Third objective is to evaluate the network performance of using openboard media and FreeNAS for local file sharing and backup to cloud storage. For the related work, for comparison in the related work, the first related work that I refer is home server and NAS using Raspberry Pi. The area focus is the transfer rate of file directly to the Raspberry Pi, and security is the same as mine using OpenVPN secure connection. For the performance test, it measures download rate and upload rate only, and the connection speed is fixed. For my project, the only difference is that the area focus that the area that I'm focusing is the transfer rate of NAS, and also backup to offsite server with built-in encryption. And the performance test is I'm measuring download and upload rate of NAS and to the offsite server, and also the network performance of before and after applying OpenVPN. For the connection speed, it is fixed. This is the network diagram of my project. There are two users here and two different NAS. One is Open Media Vault, and another is FreeNAS. For the performance test, there are three conditions. There are three conditions. First is upload and download rate in LAN. Second condition is upload and download rate in OpenVPN, which is the one which is 1. And third is backup and restore rate. Additionally, there are also network performance to be measured on both software. For the upload and download rate, there are 10 files with different size. It range from 50 megabyte to 4 gigabyte. For the upload and download rate in OpenVPN, the size of the file is reduced to 5 megabyte, from range of 5 megabyte to 250 megabyte. Now I'm going to show a demo on how the project is executed. Now I'm going to show you the transfer in LAN. Now we're connected. I'm going to transfer 60 megabyte. And finish it 12 seconds. Yeah, this is upload rate for FreeNAS. Port use is 36622. Same size. Upload. Finishing 30 seconds compared to Open Media Vault, 12 seconds, about the same. Here how's the transfer in OpenVPN works. As seen here, we are already connected to the OpenVPN server. Same with the NAS. Initial sequence completed. Now for transfer, the IP for open vault media is 10.8.0.4. I'm going to transfer size of 20 megabytes. Yep. For FreeNAS, same transfer. In here, FreeNAS is considerably slower. FreeNAS finish in 90 seconds, while Open Media Vault finish in 4 seconds. For the backup and restore, for Open Media Vault, it uses Duplicati, third-party backup program. We run now. The way this backup works is that if the source data that is going to be backup match with the destination folder, it will not do it will not transfer it will not doing the transfer. But when there is a modification on the original file, it will transfer the file that only modified. Wait, like here for example is verifying files. It should not be doing any backup. It's just verifying files to see if they match with the source data. Now that is done. For FreeNAS, basically it's the same as Duplicati. If the original source data does not modify, it will not do any backup. Like here, check 100%, meaning that no modification is done on the original. Here are the result of the testing in LAN and in OpenVPN. In LAN, Open Media Vault have higher transfer rate than FreeNAS, which is the same case in the OpenVPN. Here are the result of the IPv3 on OpenVPN and LAN. Open Media Vault also it seems to have higher throughput and bandwidth transfer rate. For the backup and restore rate, FreeNAS seems to have higher rate than OpenVIDIA Vault. In conclusion, through designing and configuring NAS for this project has given me a lot of useful information on how file server works in Soho environment. Additionally, the result gathered in chapter 5 can also help people who want to build NAS server in home environment. Future recommendation: the connection speed of both client and server is tested on variable connection speed to measure performance of transfer speed in low speed environment. The environment of this project, furthermore, the development of this project is to move where port forwarding can be enabled. This will provide opportunity on comparing network performance on one connection before and after connecting to OpenVPN.